Hi everyone, I'm Jay and welcome back to my video. And for today's tutorial, I am going to help you in dealing with functions that you may find difficult to integrate. And this method I am going to show you in this video is about integrating proper fraction. Sometimes we could not use the basic integration rule that we had already been discussed in integrating fraction. Therefore, it is very important that we decompose the fraction so that we can apply integration. And this method is called partial fraction decomposition. Fraction can be classified as either proper or improper fraction. When we say proper fraction, the degree of the numerator is less than the degree of the denominator. So therefore, an example of a proper fraction is x over x squared plus 1. Since our numerator is at the first degree, while our denominator is at the second degree order. Okay, so we also have x cubed over x fifth plus x fourth plus 2. This is as well a proper fraction. We have third degree order at the numerator and we have fifth degree order at the numerator. And we also have what we call improper fraction. When we say improper fraction, the degree of the numerator is greater than or equal to the degree of the denominator. So basically, when we say improper, magkapareho ang exponent ng numerator at saka denominator, and at the same time, ang degree ng numerator is greater than compare sa degree sa ating denominator. Like for example, x over x plus 1, take note they have equal exponent, first degree, numerator and the denominator has also the same order, which is in first degree. Therefore, improper fraction siya. We also have x squared over x plus 2. Take note that our numerator here is at the second degree order, and our denominator is in the first degree order. Okay, this is in second and this is in first order. So therefore, it is classified as improper fraction. Okay, so in this video, I'm going to show you how to integrate proper fraction. So I have here an example. I have prepared an example. We have the integration of 2x over x squared minus x minus 2. So this is a proper fraction since the numerator has in the first degree while ang second denominator natin is at the second degree. So therefore, it is a proper fraction. So take note, when you look at the fraction, hindi mo magagamit yung basic integration rule into this. We have the, diba, in the basic integration rule, we have the power rule, we have the logarithmic rule, we also have the exponential rule. But in this case, we cannot actually use that in this problem. Okay, what are we going to do here is to decompose the fraction. When we say decompose the fraction, we divide the fraction into several fractions. Okay, so if we, the first step here is to check whether ang denominator natin is factorable o hindi. But in this case, we knew that the denominator here is factorable. Okay, so let's try to factor the denominator. Okay, we have denominator that is x squared minus x minus 2. We can factor this into what? X minus 2 times x plus 1. If hindi mo pa alam paano mag-factor, please review your algebra. Okay? In this case, we can actually rewrite the function into integration of 2x over x squared minus x minus 2, that is equal to the integration of 2x over x minus 2 x plus 1. So in this case, we can now use partial fraction. Okay, so let's decompose 2x over x minus 1 times x plus 1. So don't forget dx. Okay, 2x over x minus 2 times x plus 1 is equal to, now if you want to decompose this fraction, you assign a numerator variable in the numerator. So let's say our first numerator here is a over x minus 2 plus b over x plus 1. Okay, so we have numerator a for the first term and we have numerator b at the second term. So our goal here is to find variable a and variable b. Okay, so how are you going to do that? So apply algebra operation. Okay, so we know that it is 2x over x minus 2 times x plus 1 is equivalent to, so if we get the common denominator of a over x minus 2 plus b over x plus 1, so we can actually get that the third common denominator is x minus times x plus 1. Okay, then you add the two fractions, then we can say that x minus 2 times x plus 1 divided by x minus 2, so the result is x plus 1, correct? Then multiply x plus 1 to a, the result would be a times x plus 1. So this is how it goes like this. Now we have x minus 2 times x plus 1 divided by x minus 2. Cancel out x minus 2, the remaining would be x plus 1. Then multiply it by a. So that is a times x plus 1. Okay, so after this, now it's just like you are just adding two fractions. We have 1/2 plus 1/3. What is their common denominator? They have 6, correct? 6 divided by 2, 3 times 1, that is 3. So 6 divided by 3, that is 2 times 1, that is 2. Okay, so that is the same operation. Then after this, we have plus b times, the remaining would be x minus 2. Okay, so we knew that they have common denominator. We have 2x over x minus 2 times x plus 1. And we also have the denominator at the right side is x minus 2 times x plus 1. So we know that if we cross multiply these two fractions, we can cancel out the denominator, correct? We can cancel this out. So the remaining would be 2x is equal to a x plus 1 plus b times x minus 2. Okay, so we have now this equation. No, since your goal here is to find a and b, okay, so you assigned any value of x. So you assign any value of x. So set or assign value of x, but make sure ang i-assign mo na value ni x is a value which you can easily value na maraming o pwedeng may ma-cancel out, no, para hindi mahaba yung equation. Actually, you can assign any value of x. Pwedeng 1 hanggang infinity. But in this case, para mas maging madali yung ating computation, you assign value ni x na merong pwedeng ma-cancel or maging 0. Okay, so in this case, we knew that our x here is equal to negative 1. Okay, it's equal to negative 1. So we assigned negative 1 sa value ni x, that is 2 times negative 1 is equal to a times negative 1 plus 1 plus b times negative 1 minus 2. Okay? Okay, so after this, you simplify. With 2 times negative 1, this is equivalent to negative 2. Then, this is the reason why we assigned negative 1. So, since a times negative 1 plus 1 is equivalent to 0. Okay? So, then, that is b times negative 1 minus 2, that is what? Negative 3b. Correct? So our result here is b is equal to 2 over 3. Okay? So we have already computed for the value of b. And this time, let's compute or let's try to get the value of a. So ano bang mas madali nating i-assign na value kay x? Okay? So in this case, siguro we set x is equal to 2. Why 2? Because if we put x here at b times x minus 2, we can easily get 0 into this, no? Since 2 minus 2, that's equivalent to 0. Okay, so let's try to, or let's substitute the value of x here. We have 2 times 2 is equal to a times 2 plus 1. And after this, plus b times 2 minus 2. So we can cancel this out. Correct? That is 0. Therefore, we have the value of a that is a is equal to 4/3. So we have now the value of b, which is equal to 2/3, and the value of a, which is equal to 4/3. Okay? So now let's substitute the value of a and b. So therefore, we can say that 2x over x minus 2 times x plus 1 is equal to, so let's use this equation, this one here, that is equal to, we have 4/3, that is our value of a, over x minus 2 plus our value of b here, that is 2/3 over x plus 1. So let's integrate our function. Okay, so let's try to integrate this one. We can say that the integration of 2x over x minus 2 times x plus 1 is equal to the integration of 4/3 over x minus 2 dx plus the integration of 2/3 over x plus 1 dx. Correct? Okay, so we can actually take our constant 4/3 outside of the integration. That is 4/3, then dx over x minus 2 plus 2/3, the integration of dx over x plus 1. Okay, so what do you think the integration rule that we can apply into this? We have the integration of du over u, that is the natural logarithm of u plus c. Correct? So in this case, our u is x minus 2. So therefore, our du, that is dx. So therefore, in the other side, we have our u here is equal to x plus 1. Then our du is dx. So we can have our integration, which is equal to 4/3, the natural logarithm of x minus 2 plus 2/3. Then we have the natural logarithm of x plus 1 plus c. Okay, so that is the integration of 2x over x squared minus x minus 2 dx. So I have here a new example, which is the integration of 2x squared plus 3 dx over x times x minus 1 squared. So we knew that based on the definition that this fraction is classified as proper fraction. Why? Because our numerator here is at the second degree order. Take note, may exponent tayong 2. And we also have the denominator, which is in the third degree order. Why is it third degree order? Since we know that um, our x minus 1 is raised to 2. Okay, so that could generate x squared. Then we have x variable outside of the parenthesis. So if we distribute x inside the parenthesis, that would give us x cubed. Okay, so therefore it is a proper fraction. So now how are we going to decompose this fraction? Since we know that the denominator um, cannot be integrated or cannot are already factorable with exponent. Okay, so for factor with exponent, so therefore for factor with exponent, you need a partial fraction for each exponent from 1 up. Okay, like for example, we have 1 over x cubed. Then we have to have a partial fraction of a over x. We have first exponent plus b over x squared. So we have second exponent, then plus c over x cubed. Okay, so the other one we have 1 over x plus 1/4. Then we can factor this, or we can decompose this into 1 over x plus 1 plus b over x plus 1 squared plus c over x plus 1 cube, and lastly plus d x plus 1 raised to the 4th. Okay, now what if our denominator is in second order? Like for example, we have x squared plus 1. Now, if our second order is in, if our denominator is in the second order, our numerator should be in the first order. Okay, so therefore, our numerator should be ax plus b over x squared plus 1. So our numerator here is in the first degree, while our denominator is at the second degree. Okay, so we have another example. If we have um, x squared plus 1 raised to 3, that would give us ax plus b over x squared plus 1 plus cx plus d over x squared plus 1 squared plus ex plus f over x squared plus 1 cube. Okay, so you have a partial fraction for each exponent from the first degree up. Okay, then if our denominator is at the second degree, then we have to make our first denominator at the first degree. Okay, so we have one exponent at the at the numerator. Okay, so that's how you are going to compute or to decompose a fraction with a factor, with denominator has a factor with exponent. Okay, so our goal here again is to identify the variable a, b, and c, then perform integration. Okay, so let's try to solve, since we knew that already, so let's try to solve the example. Okay, so here we can decompose it into x squared plus 3 over x times x minus 1 squared could be what? A over x. So x lang, since our exponent of x here is only 1. Now, isa lang, first degree lang yung exponent na x. So then plus, since our x minus 1 has second degree, no, has exponent of 2, then we have to get a partial fraction for each exponent, no, from 1. That is b over x minus 1 plus c over x minus 1 squared. So this is the partial fraction. Okay? Then after that, you combine a, b, and c. You add a, b, and c. That would become that is x times x minus 1 squared. So again, get the common denominator, that is, the common denominator would be x times x minus 1 squared. Okay? So therefore, if you sum up all of this fraction, you can say that a times x minus 1 squared plus b times x minus 1 plus cx. Okay, so please review your algebra. Okay, on adding fraction, no? So after this, we know if we cross multiply, we can cancel out the denominator. So the remaining would be 2x squared plus 3 is equal to a times x minus 1 squared plus bx x minus 1 plus cx. So now, compute for A, B, and C. Okay? So how are you going to determine A, B, and C? By assigning any value of x. But again, you assign a value of x that would easily compute the variable. At make sure yung i-assign natin na value ni x ay yung may makakancel tayong term or may ma-equivalent to 0. So in this case, we know that our value of x here is equal to 1. Why 1? Since we have x minus 1, and that would give us a difference of 0. Okay, that is 2 times 1 squared plus 3 is equal to a times 1 minus 1, 0, plus b times 1 minus 1 plus c times 1. Okay, so this is 2, 1 squared plus it is equivalent to 5. Am I correct? Is equal to this 0. And this is also 0. Okay, since 1 minus 1 that is equivalent to 0. So the result is C is equal to 5. Okay, so we have already a value of C. Now, let's assign other value of x. So our x here could be equal to, let's say that's equal to 0. Okay, so let's try. That is 2 times 0 squared plus 3 equals to a times 0 minus 1, that is equivalent to negative 1 squared, plus b times 0 minus 1 plus c times 0. So it would give us 3 is equal to negative 1 squared, that's still a. Since we have b times 0, it's all equal to 0, and c times 0 is equal to 0. So easily we can get a is equal to 3. Okay, now let's try to assign value of other value of x so that we can get or we can compute for the value of b. Okay, so what do you think could be the value of x? Okay, so let's try, I think let's try 2. Okay, so we have 2 times 2 squared plus 3 is equal to a times, since we have x minus 1, that is 2 minus 1, that is equal to 1 squared, plus b times 2 times we have x minus 1, that is 2 minus 1, that is 1, plus c times 2. Okay, that would give us 4 times 2, 8 plus 3, that is 11, is equal to a plus 2b plus 2c. Now we already have a value of a and a value of c, and that is 11 is equal to, what is our value of a? That is 3 plus 2b plus 2. What is the value of c? That is 5. Okay, so therefore we can get our b is equal to, we have 11 minus 10 minus 3 is equivalent to negative 2. Since we have 2, negative 1. Okay, so we have now already computed a, b, and c. So we have a is equal to 3, b is equal to negative 1, and c is equal to 5. We substitute a, b, and c into our partial fraction. Okay, we have, let's rewrite our problem, that is 2x squared plus 3 over x times x minus 1 squared. And this can be written as it is the integration of a over x plus b over x minus 1 plus c over x minus 1 squared. And this is dx. So we substitute the value of a, b, and c into this partial fraction. That is the integration of, what is the value of a? We have 3 over x minus, what is our b? That is minus 1 over x minus 1, and we have plus our c, that is 5 over x, that is x minus 1 squared. Okay, then dx. So we can now apply integration rule to this. So we integrate separately, that is 3 over x dx minus the integration of dx over x minus 1 plus the integration of 5 dx over x minus 1 squared. Okay, so let's take constant out of the integration, that is 3, the integration of 1 over x dx minus the integration of dx over x minus 1 plus 5 integration of dx over x minus 1 squared. So integrate, we can say this is what? 3 natural logarithm of x minus the natural logarithm of x minus 1 plus 5. This is power rule, no? Since if you, since the exponent of the denominator is not equal to 0 or 1, so therefore you can apply power rule to this. That is x minus 1 raised to negative 2, since you take the denominator above, no? You transfer it at the numerator, so you have a negative sign, so plus 1 over negative 2 plus 1, then you have plus c. Okay, that is equivalent to 3 natural logarithm of x minus the natural logarithm of x minus 1. Then we have negative 5 x minus 1 raised to negative 1 plus c. Okay, so let's put the negative, I'll change the negative exponent to positive. So we change that into a positive exponent. So we try to put it at the denominator. Okay, that is equivalent to 3 natural logarithm of x minus the natural logarithm of x minus 1 minus 5 over x minus 1 plus c. So this is the integration of 2x squared plus 3 over x times x minus 1 squared.